in today's lecture, we will talk for quick, just overview in sensors and instrumentation, and we will go through Wheatstone bridge. And for this topic, there's a homework from supplemental problem set, page number 36. This will be about applications on Wheatstone bridge. While sensors and instrumentation, we will go just overview. So it's just like the fundamentals for this, so you can know what does sensors means and how can we use this as just concepts without examples. But before going to that, I just want to go for like a quick notice on the machines, or in general, when I say machines, I mean motors and generators. So we have discussed three-phase synchronous motor, three-phase synchronous generator, and three-phase induction motor. And I would like to mention, like, just for example, this example, if you see the given information, 480 volts, 6 poles, 150 HP, three-phase synchronous motor, and the same for the generator and for the induction motor, you will see this information. So usually this information will be given through we call it through the nameplate or the data sheet of the motor or of the machine itself, motor or generator. So somebody can say, when I see, for example, this, what does this number mean? That's what I want to focus about, the power. 150 horsepower. So we know 1 horsepower equals 745.7 watts. So if I just say like 150 times 745.7, then I give this number. Then if someone said, can I use this number as output power? The answer is no, we will not use this number. But why? So why we will not use this number, but why this number is given? It is given, yes.
Is that the maximum power output that the machine can have?
Usually we call it, this one is the rated power, and we can say like we should not exceed this value. Then it's the concept is the maximum power. We don't prefer to say it's the maximum power. We can say we prefer to say it is the rated power. So the rated power, this motor or this generator is designed to be work at max this value. So does this mean if I run the generator or the motor more than this value, will this motor break out? The answer is no. But if I work on short term, it will work okay. But if I work for long term higher than this value, then the motor will be affected, or the generator will be affected. So this value is the recommended value, the high recommended value, or the maximum recommended value. This is the best word for this. Or we used to call in electrical engineering the rated power. So when you see this power, and usually the rated power, in generator usually given as maybe megawatts or kilowatts, or in general in watts, or sometimes on volt ampere for the generator. While in motors, usually it will be given in horsepower, HP. And the horsepower, as we know, is 745.7 times HP, horsepower, to get watts. And usually the rated power, we call it the maximum or recommended power for the machine at long term. So it is not recommended to exceed this value that we will see. And usually this will be from the data sheets. Data sheet or nameplates. So we will see this a lot But in general, we will not use it in our analysis. So some of the mistakes in the last quiz, some people use this value. Or in the generator, it was in watts. So some people use this value as watts. But in general, you will see working condition. So what we will use, we should use working conditions. So usually, the working condition will be given. What does I mean by working condition? For the generator, for example, you will be given the value of the load, for example, or the power of the load, and the power factor. So when can I use the rated power? I can use it if and only if I set the working condition equal to the rated power, then I can use the rated power. But in general, I will mention this. If working condition equal rated power, then this is the only condition we use rated power. Okay? Any question about this? So just you need to take this into consideration for when you solve your questions or during your quiz. So you'll see this also in your today's quiz as well. Okay, so now let me go to the overview on sensors and instrumentation. This is the only slide for chapter 7.1 that's required from you. So sensors and instrumentation. So what do we mean by sensors? Any thoughts? Sensors. So when I say sensors, from sensing, what does sensing mean?
Like find a kind of value and convert it to like an electrical or digital signal.
Yeah, in general, sensors is something like I convert something physical to be understandable. Like we know the human body has 5 senses. So just we use these senses, then our brain can understand or can solve this. So in electrical engineering, sensors convert the physicals into electrical signal. So sensors like what? Like temperature sensor, for example. For the AC, for the central units, we have a temperature sensor. So how does this work? It is by converting the temperature into the electrical signal. And this electrical signal, based on, we have programmed it based, if we have a certain value, after that, the AC will work. So if the temperature go below, for example, a certain unit, then turn on heat. And if you set it on cold, then if the temperature goes higher than a certain value, then it will work. So the temperature sensor is one of the most important applications. And what else? What other examples of the sensors? Any thoughts?
You could have like a pitot tube in an airplane measuring airspeed.
Yes, we have also a speed sensor, right?
Yeah.
So the speed sensor is depending on which type. We have a lot of types of speed sensors. One of the types is the mechanical speed sensor. So that's attached to the rotor of the motor, so it can measure the speed. And one of these other types of the sensors is by using light sensors, or sometimes some people using laser or ultrasonic sensors to measure the speed. So they can measure like RPM speed. So after that, we can convert RPM to radian per second and use it in our system and apply it. What other sensors? There are many ways. One of the types of the sensor is called LDR, or we call it light dependent resistor. So this sensor, it's sensitive resistor. It's changing. It's the equivalent value for it is a resistor, and it's changing depending on the light. So if we have there is no light, then there will be a certain value of the resistor. And if there is a light, it will be changed. So based on that, we can apply these sensors to many applications. And we have also another sensor, it's called force sensor resistor. So it is the same resistor changing depending on the force applied to our system. So this is one of the examples of the sensor: light sensitive resistor, temperature sensitive resistor, force sensing resistor, and speed meter as well. So after having these sensors, what should I do? So then I can apply what application I want. So in general, for any system, if I want to control it, what should I have? I need to have objects to be controlled. Is that right? I need to control an object first. What should I control? I want to control the temperature, I want to control the speed, I want to control the car or the speed of the motor, the position of the motor. So I need to determine my target. After that, I need to have something we call a controller. Is that right? Why do I need to have a controller? To apply the controlling object. So if I have an object that I need to control, for example, if I'm driving a car, I want to control the speed. How can I control the speed? By using the accelerator, just pressing the accelerator, is that right? Just pressing the accelerator so I can control the speed. And what I'm controlling the speed of the car. So the object to be controlled is the speed of the car, while the controller is the accelerator. So is that enough? So who decide what's the speed? For example, if I want to set the speed, we call it here reference value or desired value. If I have desired value, so for example, desired speed value, desired temperature value, is that enough to say this is the desired value and just turn on the accelerator? But if I'm doing that, how can I say to the accelerator stop? How can I know I have reached the desired value? So if I have reached the desired value, I need to move my leg from the accelerator. Is that right? So who decides this? How can I know that I have reached the desired value? How can you know? If you drive in the highway and like the speed is 70 miles per hour, how can you know you have reached this value?
You'd have a gauge, like your speedometer, and then your input by letting off the gas.
Yes, you have the speed meter. So you just look at the meter. So in this case, I need to have what? A sensor, is that right? So I need to have a sensing way to sensing the speed. So we call it a feedback. So sensor. After that, I compare my desired value with the actual value. So the speed, find the actual value. Then the error will go to the control signal. For example, the actual speed is 0, the desired speed 770 miles per hour. Then what's the error? It's 70. So I'm pressing high on the accelerator. Then after that, I read the speed and see, oh, I'm reaching 40 miles per hour. Then I'm still pressing on the accelerator, but maybe less than what I was pushing last time. Then until reaching 70, then the error will be 0. So there's no need to continue on pushing toward the accelerator. So I will turn off. Not turn off, we call it, there's no need, the error signal will be 0. What else What's other application? Like if I'm working, if I want to like control the temperature. So I'm controlling the object to be controlled is the temperature. Then the controller is what? The AC unit. And the sensor is the temperature sensor. The reference value, for example, 70 Fahrenheit, and the actual value is 65, then I'll turn on the heat until reaching that, until the air will be 0. So for example, car, then if you have the reference value 700 mile per hour, and you have error signal here, the controller accelerator, and the object to be controlled, speed of car, and the sensor is what? Speed meter. So that's, we call it the control or the block diagram of the car. And if we have temperature control, then I have a reference which is, I would say 75 Fahrenheit. I have what? AC units. And I have temperature or room. Then I have what? Thermistor. So this, sometimes we call it block diagram or control block diagram for the system. So any system that I want to control, I have to follow this. In general, the object to be controlled exists depending on what I want to find, like speed of the car or the room temperature or something. And the controller is usually on our hands. Like we have the car, we have the accelerator, we have the AC units. So where is the engineering parts? It's not only like in the production of those, but the other engineering parts is here, and how to apply the controller. So we need sensors. So every time, if I want to control anything, I need sensors. And even for the human body, if you want to walk, for example, go to the classroom. So what's the object to be controlled? Your body. What is the controller? The controller is your hand, your legs. What's the sensors? We have 5 senses. So these are the sensors. And what's the desired value? Go to the classroom. What's the actual value? For example, if I'm at Shelby, this is the actual value. Then after that, I'm at Ramsey, then I'm at Sanford, then. So that's what I'm reading. And the sensors is, for example, my eyes. And as I said, like the 5 senses. So the actual value is keep changing, while the desired is based on you. So you determine what's the desired. But the actual, you have access by using the controller. So what's your target? Your target is to let actual equal reference. So your target here is to let speed actual speed equal to 70 miles per hour. Or here your target is to let temperature equal 75 degrees. So you need to have a target, you need to have the object to be controlled, you need to have the controller and sensors. So here sensors, usually there will be a physical sensors. So we have talked about the human body, we have talked about some electrical sensors. So these are very important for you to understand this. I mean, even though like for this information, you will not be tested on this. But you need this information will be for you. And you will not find this on the textbook. Okay, so we've talked about the sensors. It's just converting the idea of the sensors, converting the physical simulation to electrical signal. And why I talked about the control, how to control this, because this is why the sensors are exist. Why we created sensors, we've invented sensors to apply them in our control system. So it's not enough just to say like there's something we call it sensors, and they are converting physical quantities to electrical. Yes, it's important to know that, but this is not enough. You need to understand why I'm using sensors. And we have something, we call it like we want to amplify the signal, or we want to shift the signal from range to range by using conditions. And we will not go through this part. And there is one like applications called Wheatstone bridge. So what is Wheatstone bridge and why we are using this? So Wheatstone bridge is usually voltage source with 4 resistors. It's just the same equivalent circuit, and you need to know this equivalent circuits. And usually it's DC. This is one of the applications on DC. So it will not be that difficulty. So it's DC source, resistor, resistor, resistor here, resistor here. So that's Wheatstone bridge. DC source with 4 resistors. Why we are using this? We are using this here because there's 2 points here, both A and B. There are many ways or many applications for that. But one of the applications said if this one, for example, RF, which means they are all the same value, and this one RF. So if all these resistors are equal to each other, then the voltage difference here, VAB equals 0, if all are equal RF. While if one of these resistors is not the same, then these resistors will not be, the VAB will not be 0. So this is the first thing that you need to know. If all these resistors are zeros, are equal to each other, all of these 4, then the output here between A and B in the middle will be 0. Why we are using this? What's the application? We are using this if we want to measure a resistor. One of the applications, resistor measurements. How? If we, for example, put a certain resistor here, if we put three known resistors, and the 4th resistor is unknown, if I said RF, A, E, RF, and this one let me still call it RX. So all of these are not 3 the same, but the 4th is not the same. So here, in this case, VAB will not be 0 because they are not exactly the same. But what's the advantage of knowing this? If I measure the voltage between A and B by using voltmeter or digital multimeter, then I can know the value of this resistor. So I can measure the value of this resistor using the voltmeter. How? We will go through the analysis. How can I find Rx? But this, like what we will use here in this course, like what we'll focus. We will use this to find the unknown resistor or to measure the resistance meter. Why we are using this? Because sometimes we know for the thermistor or the photoresistor, which is the resistors are changing, or the sensors that have resistors changing with maybe with temperature or with light, how can we measure this? How can we convert this to electrical energy by using Wheatstone bridge? So the target here is to measure the unknown resistor. Measure Rx unknown. So that's what we will use here. And how can we use this? It's simple. This is the circuit of the Wheatstone bridge, and this is the derivation. We will not focus on the derivation. The only thing that you need to focus was this and this. So this one is called exact formula, and this one is called approximation formula. So I want to say, like, just you need to write this in your note card. They say like V out equal to VDC times Rx over Rx plus Rf minus 1/2. So V out equal VDC over 4. If I assumed Rx equal Rf plus delta R, so I can find delta R.
So will this be on our test on Friday?
No, this will be on for the final exam, but will not be on Friday test. The Friday test will be until the end of Friday's lecture, last Friday lecture. Okay? So here, Rx equal, if we assume Rf plus delta R, then we can find delta R. So VDC is known. Rf is known. Is that right? 1/2, we have it. V out, if we use digital multimeter to measure V out, we can know it. So if we know V out, we know VDC, we know Rf, we know 1/2, so we can find Rx easily. Is that right? If we look at the approximation formula, we have VDC, we have Rf, we have V out, so we can find delta R by applying the approximation formula. Is that right? So that's how we can find the resistor. There are many applications, physical or hardware applications, we are using this. Some of the applications in a device we call a Megger is to determine where is the fault of the transmission line. If there is a tree falling on a tree, we use it for the underground cables. Sometimes some underground animals like rats or something, they are going to the underground cables, and these cables will be having, we'll call it fault or short circuit on these cables because of these animals, underground animals. Then these cables will be the service or the electrical system will turn off because of this. Since these cables are underground, then we couldn't know the place of the fault because they are underground. We didn't know. How can we know the short circuit location? We are using a device is called Megger. This device is usually to determine at what distance that's happening, and it's very accurate. So if we're using this device, it's based on Wheatstone bridge. We can find the unknown resistor and we know resistors equal to L over sigma A. We have the cross-section area, we have sigma, then we can determine the length. Then if we determine the length, we can say like after, for example, 200 meters, there you can find the short circuit here. Then you can start digging, then find the short circuit, solve the problem, and return the electrical service. And usually this device Megger is used for underground cables. Okay? Here you will see the derivation. How did we reach to this? But in general, it's not required from you to know the derivation. It's required from you just to know the V out exact formula and the approximation formula. And just quick, here you need to know if Rx equal Rf or if delta R equals 0, here, then V out will be 0. Let me put here. If Rx equal Rf, then delta V out equals 0. Or if delta R equals 0, No, it's not delta V out. V outwards. V out will be 0. It's just, if you look at the formula, if delta R equals 0, V out will be 0. If RF equal Rx, this one will be 1/2, so it will be 0. Okay? That's what I was saying at the beginning. Okay, let's see an example. So the WB, this means Wheatstone bridge, when you see this way. So usually you are required also to know the circuits and these two formulas. It's your responsibility to know this. I mean, and if you have a question on Wheatstone bridge, you need to draw the circuit first, then start your analysis. So you can also write this on your note card as well, or on your note sheets. So WB means Wheatstone bridge. So if we have resistors 120, and we have a certain resistor has delta R equal 0.246. So what is V out when we DC equal 10 volts? Let's draw the circuit. It is 10 volts DC, and we have a resistors 120 ohms, 120 ohms, this one B, this one A, and we have here Rx, which is 120 plus 0.246. That is RF plus delta R, which is Rx. And the rest are RF. Okay? So how can we find this? If we want to use the exact formula, just VDC times Rx over Rx plus Rf minus 1/2. This one exact. If we want to use approximation, it is V out will be VDC over 4 times delta R over Rf. We have Rx, we have RF, we have VDC. Just plug the numbers. It's a simple application. So I consider this application is very easy application. And if you find like a question, for example, in the final exam about this, then this will be just a gift for you because it's easy. Simple. Just like find V out and that's it. Or sometimes find the unknown resistor. So I recommend to see also the supplemental problem set to explore more about this. And in general, we see here V out equal 5.12 millivolt, 5.1 millivolt. So V out is recommended in some applications. If we want to have the resistors here, it's recommended to be 0. If in some applications, it's depending on the application. If we are using, for example, resistors, and these resistors are varying with each other, so it's recommended to make these output to be 0. So sometimes this value will be considered as a sensitivity of the device. We will not go through that sensitivity of these analysis because they will be this will be too much for you. So we will stop until here. Okay, so let me end up this meeting.